Hello guys, welcome to this session on cloud infrastructure topology. So when designing modern enterprise architectures, selecting the right compute is the most critical decision, and kind of over provisioning leads to some you can say massive financial waste. Okay, so today we are going to break down the AWS Compute Service. Okay. And this is the matrix which shows the AWS compute ecosystem into five distinct operational paradigms, you can say, that are virtual servers or EC2s, serverless function, that is Lambda, and we have container orchestration. So then we have the kind of simplified compute, or we can say Lightsafe, and then we have the specialized kind of enterprise compute. So now let's discuss each column, okay, from an architecture and kind of business standpoint. First of all, we have the major EC2, that is Elastic Compute Cloud. So EC2, like AWS, it is kind of AWS Compute, which is kind of raw virtualized hardware. And EC2 is going to grant you root level control over the operating system kernel, storage structure, and the network boundaries you can see. And there are like different instances, and it was like segments is to highly optimized family types, uh, target some specific workloads. So we have T3 and M5, that is the main purpose. Okay, that is used for finance, compute memory, and networking for standard packets. We have C5, and that is compute optimized, and that is used for high performance processor, that is used for batch processing and media encoding. Then we have R5, that is kind of memory optimized, that is used for like handle massive data sets in memory, either for high performance data sets. Then we have GPU, and that is accelerated hardware designed for machine learning, training, and deep data modeling. Then we have the like the financial, or you can say financial purchasing model. So like to manage EC2 cost. So like it is like defining how we are going to manage EC2 cost that is required for FinOps procurement. Okay. So here we have our own demand. So like this is like a pay by the seconds with no commitment, and it is kind of mesh for unpredictable or kind of busting workloads. Then we have saving and saving plans and user instances, that is we call as RIs. And here like it commits to a consistent compute configuration for a 1 or 3 year terms to lock in, and you can get up to like 72% discount. Then we have the spot instances. Like here you are going to build on unused AWS data center capacity at up to 90% discount. And AWS can reclaim those particular instances with 2 minutes warning. So meaning like the spot instances is kind of strictly reserved for stateless or fault tolerant batch workloads. And also you can say EC2 instance, it doesn't live in isolation. So it relies on AMIs, that is the Amazon Machine Image, to boot its OS configuration, mount a persistent EBS or elastic block storage, network overload for store VIPs, and to secure its boundary, it is using security groups and IAM stance laws. And it is like ideal for some kind of legacy migration application using lift and shift, and for heavy monolithic applications and custom database cluster where you require kind of absolute hypervisor control. And next we have AWS Lambda. We also can as serverless compute or kind of functionality services. So it is kind of event-driven serverless compute. With Lambda, you completely break your dependency on the underlying OS and virtual machine management. So, like, what is the execution model for here? Okay. So here you are going to upload kind of code functions that could be in Python, Node.js, Java, Go, Ruby, and .NET. And AWS is going to completely handle that provisioning, scaling, fetching, and high availability in the background. And here, Lambda functions kind of sit in idle state until they are open up by an incoming, you can say, a native API gateway event trigger. Okay, this includes landing a file in S3 buckets, a new record inserted into some dynamic DB table, or some HTTP hit on some API gateway, or an enterprise message queue that is ingested via the SQS. So if we talk about the pricing, so in this case for invocation pricing, so like traditional servers use billings for 24 by 7 if there are like zero users login. And Lambda features a kind of a pay per invocation and millisecond duration pricing model. So if your code runs for 50 or 40 milliseconds, so you are only billed for those 40 or 50 milliseconds, and it can scale down to absolute zero also when it is idle. And what are the enterprise use cases? So it is used for real-time data processing pipelines and kind of some asynchronous microservices. Also, you can schedule your own automation, and it is also used for stateless API packets. Then the next is kind of AWS Container Services, or you can say managed microservice fabric also. So here we have containers, that is containers technology, we can say ECS, EKS, and target. So it targets a containerized microservice architecture that is built to use in Docker or some OCI compliance standard. So uh, here we have the orchestration choice, there has kind of ECS versus EKS. So ECS is kind of Elastic Container Services. So here, it is kind of AWS native container management solution. It integrates deeply with the cloud native constructs like IAM, CloudWatch, and ALB with the minimal configuration complexity. Then we have EKS, that is Elastic Kubernetes Services. It is kind of a fully managed Kubernetes platform, and it provides standard Kubernetes APIs uh, that is compatible with the backend, and it is kind of making it for the industry choice for our organization, like deploying pros, cloud, multiple from workloads as well. Then we have a Fargate, or kind of a serverless container. So when you are running ECS or EKS, so you must decide where the container physically execute. So you can register traditional EC2 instance as workloads, so which forces you to manage the underlying server scaling. And also you can select AWS Fargate. Fargate kind of turns your container environment serverless. You simply request explicit CPU and memory allocation for a container manifest, and AWS is going to provision the isolated execution specs on demand. And if we talk about the supply chain for exporting ECS and EBS, we have the ECR. So you can pair your own orchestration cluster with ECR, that is Elastic Container Registry, to store, scan, and manage your private container images kind of securely. So it is ideal for kind of standardized microservices, multi-tier web application, and hybrid container deployments. And the next one is the Amazon Lightshell. So it is kind of simplified and virtual private servers. So it is for kind of low complexity infrastructure management. And Lightshell provides a dashboard that wraps compute storage, networking, and database into pre-packed bundles. So unlike standard AWS pricing, where variables like network, gas, and IOPS can fluctuate with this, so Lightshell is going to utilize fixed, predictable, flat monthly pricing tiers. So also it is going to simplify networking and kind of blueprints. So it is going to bypass complex VPC subnetting and security configuration. It allows the developer to like deploy instant pre-configured application blueprints, such as kind of single click WordPress, magnet flow, or lab stack with setup. So and like what are the use case? So it is used for kind of rapid prototyping, independent sandboxes, development tools, small blogs, or some kind of low traffic marketing websites. And in the last, we have that additional compute options. Like these are the edge case compute framework designed for unique enterprise data topologies. So first we have the AWS batch, which is kind of a fully managed batch processing unit. So it automatically provisions skills and dismantle massive cluster of compute resources to execute kind of large-scale parallel processing jobs based on some centralized job use. Then we have October. So it is a highly streamlined PES that is platform as a service kind of kind. It is kind of allows developer to connect straight to source code repository or a container registry, and instantly you can deploy a secure web-facing application with automated load balancing and SSL generation, and like completely spicing that ECS and Kubernetes cluster administrator as well. Then we have the AWS Outpost, which is kind of hybrid cloud framework. So here, like AWS is going to ship and install physical enterprise-grade servers directly inside your on-premises data center, and Outpost runs like these exact AWS APIs, control planes, and kind of management tools locally on the Outpost. So you are allowed to run hybrid application with some sub-millisecond like the local network latency while you are able to manage or you are able to maintain that unified control via the Windows console. And that's it from this particular session. I will see you next session. Thanks.